According to a new study, both sides of the two-sided perovskite solar element receive sunlight, which potentially allows it to achieve higher energy output at lower overall costs. Two-sided solar elements capture direct sunlight from the front and reflected sunlight from the back. As a result, according to the National Renewable Energy Laboratory (NREL) study, they outperform one-sided solar elements. This perovskite cell can work very effectively from any side, said Kai Zhu, a senior scientist at the NREL Center for Chemical and Nanosciences. In previous research, two-sided solar elements could not compete with one-sided elements, which currently have an efficiency of 26%. According to NREL researchers, ideally, a two-sided cell should have front efficiency close to the most efficient one-sided cell and similar rear efficiency. The researchers found that the perovskite layer on the front of the cell should be thick enough to absorb most of the photons from a specific part of the solar spectrum, but if the perovskite layer becomes too thick, it can block photons. The NREL team also needed to determine the ideal thickness of the back electrode on the back side of the element to minimize resistive losses. Using modeling, the team found that the ideal thickness of the perovskite layer is about 850 nanometers. Compare this to the thickness of a human hair, which is about 70,000 nanometers. Then they placed the two-sided cell between two solar simulators and directed direct light to the front side while the back side received reflected light. The efficiency of the cell increased as the ratio of reflected light to frontal illumination grew. The research group notes that the two-sided perovskite solar module will cost more than the one-sided module, but the higher initial cost will be offset by the increased power of the two-sided modules by 10–20%.